Every year, millions of people around the world suffer from the effects of a powerful substance that promises energy, confidence, and focus, but instead damages the brain, body, and entire communities. Cocaine is often portrayed as a quick energy boost, a fast track to feeling invincible. But behind this image lies a complex chemical compound that can silently reprogram the brain, damage vital organs, and take control of decision making. This video is not about fear, it's about facts. We'll explore what cocaine really is, how it changes the brain and body, and why science proves there is no safe way to use it. Our goal is simple: to help you understand the reality behind the image and empower you and your loved ones to make informed, healthy choices. Because the truth is, cocaine doesn't improve your life, it destroys it, slowly from the inside out. Let's take a closer look at how it works and why abstaining from it is one of the most important decisions you can make. Cocaine is a powerful stimulant that acts on the central nervous system. It originates from the leaves of the coca plant, a shrub native to the Andes Mountains of South America. For thousands of years, indigenous peoples have used coca leaves in natural, traditional ways, most commonly by chewing them to reduce hunger, fatigue, and the effects of high altitude. In this form, the plant has a mild stimulant effect similar to caffeine. However, when the active compound is extracted and refined into its concentrated chemical form, the result is a far more potent and dangerous substance. In its pure state, cocaine appears as a white, crystalline powder. It interacts directly with the brain's communication systems, altering the way nerve cells transmit and receive signals. Because of its stimulating effects, cocaine increases alertness, confidence, and energy levels in the short term. These sensations can make it seem attractive or even harmless at first glance. But beneath these temporary effects lies a complex disruption of the brain's normal chemistry. Cocaine interferes with the natural balance of neurotransmitters, the chemicals responsible for mood, motivation, and pleasure. When these systems are overstimulated, the brain begins to adapt, eventually finding it harder to function without the substance. Over time, this interference can lead to serious changes in mental health, emotional stability, and physical well-being. Cocaine's history and cultural background make it an interesting subject of study, but understanding its scientific properties reveals why it poses such significant risks. In the next part, we'll examine cocaine's chemical nature, how it's classified, how it works at the molecular level, and why its effects are so powerful. Cocaine is classified as an alkaloid, a naturally occurring compound that contains nitrogen and produces strong effects on living organisms. Many plants create alkaloids as a form of protection, and humans have learned to extract and use them for medicinal or recreational purposes. Examples include caffeine from coffee beans and morphine from the opium poppy. Cocaine, derived from the coca plant, is one of the most potent stimulants in this group. In its refined form, cocaine acts primarily by altering communication between nerve cells, or neurons, in the brain. Neurons send messages to one another using chemicals called neurotransmitters, such as dopamine, norepinephrine, and serotonin. These chemicals control many aspects of human behavior and emotion, from pleasure and motivation to alertness and mood stability. Under normal circumstances, once a neurotransmitter like dopamine is released into the space between two neurons, it quickly returns to its original cell through a process called reuptake. This helps maintain balance in the brain's signaling systems. Cocaine blocks this reuptake process, preventing dopamine from being absorbed back. As a result, dopamine builds up in the brain's reward pathways, creating an intense, short-lived feeling of euphoria and heightened energy. However, this interference also destabilizes the brain's natural rhythm. When the effects wear off, the brain is temporarily deprived of dopamine, leading to exhaustion, sadness, or irritability. With repeated exposure, the brain adapts to these artificial surges and becomes less sensitive to dopamine, requiring more of the substance to achieve the same effect. This mechanism explains why cocaine has such a strong influence on both body and behavior. It's not only stimulating, but deeply disruptive to the brain's chemistry. In the next section, we'll look at how this chemical interacts with the body once processed, and why its impact can be so severe. Cocaine begins as a natural product of the coca plant, but it undergoes several chemical steps to become the concentrated substance recognized today. The leaves are harvested, dried, and soaked in solvents that extract the active compound. This process produces a paste, which is then purified and converted into a white crystalline powder, the hydrochloride form of cocaine. Each step removes natural plant components and increases the concentration of the active alkaloid, creating a much stronger and faster-acting substance than the original leaf. This purified powder dissolves easily in water and alcohol, which makes it highly versatile. Variations of cocaine are produced through further chemical alterations that change how quickly it reaches the brain and how long its effects last. These differences in form and delivery affect how the body reacts and how intense the stimulation feels. Because cocaine acts rapidly on the central nervous system, its effects appear within minutes and fade quickly. This short duration often leads to repeated use in an attempt to maintain the desired sensations. However, each exposure pushes the body's systems into overdrive, increasing heart rate, constricting blood vessels, and elevating body temperature. These changes place enormous strain on the heart and circulatory system. Even small amounts can cause significant physiological stress. The sense of increased energy and alertness comes from forcing the body into a heightened state of activity, rather than truly improving performance. Over time, this repeated stress can lead to serious damage to the cardiovascular and nervous systems. Understanding how cocaine is made and how it interacts with the body helps reveal why it is so risky. The same chemical properties that create its powerful stimulation also make it one of the most harmful substances to human health. The human brain has a built-in reward system designed to reinforce behaviors essential for survival, such as eating, social bonding, and achieving goals. This system relies heavily on a neurotransmitter called dopamine, which produces feelings of satisfaction and motivation when released. Under normal conditions, dopamine levels rise briefly in response to positive experiences, then return to baseline once the activity ends. Cocaine disrupts this delicate balance by preventing dopamine from being reabsorbed by neurons. Instead of being recycled, dopamine floods the spaces between nerve cells, overstimulating the brain's reward circuits. This produces an intense, short-lived sense of pleasure and heightened energy. However, because the brain's systems are designed for much smaller, controlled releases of dopamine, this artificial surge confuses normal signaling. The regions most affected include the nucleus accumbens, linked to pleasure and reward, the ventral tegmental area involved in motivation, and the prefrontal cortex, responsible for decision-making and self-control. Repeated overstimulation of these areas gradually changes how the brain functions. The neurons adapt by reducing their sensitivity to dopamine, meaning natural rewards like food, exercise, or social connection no longer produce the same satisfaction. This adaptation can cause a person to feel emotionally flat or unmotivated when not using the substance. The brain circuits begin to prioritize the intense stimulation provided by cocaine, reinforcing a pattern of repeated use. These changes can persist long after the substance leaves the body, showing how deeply cocaine alters brain chemistry. Understanding this process is essential for recognizing why cocaine can have such a powerful hold on behavior. It's not simply a matter of willpower. The drug directly rewires the brain's motivational systems. Cocaine is one of the most powerful stimulants acting on the central nervous system, CNS, which includes the brain and spinal cord. The CNS coordinates every voluntary and involuntary action in the body, from thinking and emotion to breathing and movement. When cocaine enters the bloodstream, it quickly crosses the blood-brain barrier, allowing it to influence nerve activity almost immediately. Once in the brain, cocaine increases the levels of several neurotransmitters, especially dopamine, norepinephrine, and serotonin. This flood of chemicals creates a surge of alertness, confidence, and temporary energy. Users may feel more awake and focused, with a heightened sense of control or ability. These effects, however, are deceptive. The body is being pushed beyond its normal limits. The stimulation of the nervous system also activates the sympathetic fight or flight response. This causes pupils to dilate, heart rate and blood pressure to rise, and blood flow to shift toward muscles. While these changes prepare the body for action, they also increase strain on the heart and brain. As the effects wear off, the nervous system experiences a rebound phase. People may feel tired, irritable, or anxious as the brain attempts to restore balance. With repeated exposure, the nervous system can become overstressed. Long-term effects may include chronic restlessness, difficulty concentrating, insomnia, and mood instability. Some individuals may experience increased sensitivity to stress, making everyday challenges feel overwhelming. Over time, repeated overstimulation damages the brain's ability to regulate itself. The natural balance between alertness and relaxation becomes harder to maintain, leading to fatigue, poor sleep quality, and reduced emotional control. These neurological disruptions highlight why cocaine is particularly harmful to the body's control center, the brain. Cocaine's effects extend far beyond the brain. One of the body systems most affected is the cardiovascular system, which includes the heart and blood vessels. This system is responsible for transporting oxygen and nutrients to every part of the body. Cocaine disrupts its normal functioning in several ways that can lead to serious health problems, even after limited use. When cocaine enters the bloodstream, it causes blood vessels to constrict, a process known as vasoconstriction. This narrowing reduces blood flow to major organs, including the heart itself. At the same time, cocaine stimulates the release of norepinephrine, a neurotransmitter that increases heart rate and blood pressure. The heart must pump harder against the resistance created by tightened arteries, which raises the risk of strain and damage to heart tissue. Because cocaine also increases the body's demand for oxygen while restricting its delivery, the imbalance can trigger chest pain, irregular heart rhythms, or oxygen deprivation in heart muscles. In extreme cases, this can lead to life-threatening cardiac emergencies. These risks are especially high when cocaine is combined with other substances that further stress the cardiovascular system, such as alcohol or other stimulants. Long-term exposure to cocaine has been linked to inflammation of the heart muscle, thickening of artery walls, and an increased likelihood of stroke or heart failure. Even young, otherwise healthy, individuals are vulnerable because cocaine can provoke sudden changes in heart rhythm without warning. The cardiovascular system operates continuously to keep the body alive, and any disruption to its balance can have lasting consequences. Cocaine's powerful stimulation overwhelms this delicate system, demonstrating that its risks extend well beyond short-term effects on energy or mood. While cocaine's impact on the brain and heart is the most widely discussed, the substance also affects nearly every major system in the body. Its powerful stimulant properties cause widespread physiological stress that can disrupt the normal function of organs responsible for digestion, respiration, temperature regulation, and immunity. One area particularly vulnerable to cocaine's effects is the digestive system. Because the drug causes blood vessels to tighten, the flow of oxygen-rich blood to the stomach and intestines decreases. Over time, this can lead to tissue damage, ulcers, and abdominal pain. Reduced appetite is another common effect, which can result in significant weight loss and malnutrition when exposure continues over long periods. The respiratory system can also be affected. Depending on how the substance enters the body, it may cause inflammation or irritation of the nasal passages, throat, or lungs. Reduced oxygen delivery, combined with constricted blood vessels, can make breathing less efficient. In severe cases, oxygen deprivation places stress on vital organs, including the brain. Cocaine also interferes with the body's ability to regulate temperature. Because it speeds up metabolism and increases muscle activity, body temperature can rise quickly. If the body cannot cool itself effectively, this can result in dangerous overheating and dehydration. In addition, prolonged exposure to cocaine can weaken the immune system, making it harder to fight infections. Sleep disruption and poor nutrition further reduce the body's ability to recover from illness or injury. Over time, these combined effects can lead to a general decline in physical health. The body's systems are interconnected, and cocaine's widespread impact shows how easily one chemical can destabilize the entire network that supports life. One of the most misleading aspects of cocaine is the belief that it can be used casually or managed responsibly. Because its effects are brief and stimulating, some people assume that occasional use carries minimal risk. However, the science behind how cocaine interacts with the brain reveals why this perception is dangerous and inaccurate. Cocaine directly targets the brain's reward system, flooding it with dopamine and producing intense but short-lived feelings of pleasure and confidence. After repeated exposure, the brain begins to adapt, lowering its natural dopamine sensitivity. This means that ordinary experiences, such as socializing, eating, or exercising, become less satisfying. As a result, the brain starts to crave the artificial stimulation produced by the substance. This process does not happen all at once. It can develop gradually, often without the person realizing how much their brain chemistry is changing. Over time, individuals may find themselves thinking more frequently about the substance or planning their day around it. This pattern demonstrates how cocaine can reshape motivation and decision-making systems in the brain, creating a powerful psychological dependence. The illusion of control also stems from the fact that cocaine does not immediately cause visible physical decline in every user. The absence of immediate severe symptoms can make it seem harmless, but beneath the surface, major physiological and neurological changes are taking place. The brain's ability to regulate mood, focus, and impulse control weakens over time. Ultimately, the sense of control that some users believe they have is itself a product of cocaine's influence. The very chemical changes it creates in the brain can impair judgment, making it difficult to recognize how much control has already been lost. The consequences of cocaine use extend far beyond the immediate physical effects. Scientific research has shown that long-term exposure can lead to significant health, emotional, and social problems that affect nearly every area of life. From a medical standpoint, repeated use of cocaine can damage both the structure and function of the brain. Studies using imaging technology have found that certain regions, particularly those involved in attention, memory, and emotional control, can shrink or show reduced activity. These neurological changes often lead to difficulty concentrating, impaired memory, and problems regulating mood. Persistent anxiety, depression, and irritability are common outcomes as the brain struggles to maintain chemical balance without artificial stimulation. The physical health consequences are equally serious. As discussed earlier, cocaine strains the cardiovascular system, increasing the risk of heart disease, stroke, and high blood pressure. The body's immune and digestive systems can also be weakened, resulting in frequent illness, weight loss, and nutritional deficiencies. Chronic exhaustion and disrupted sleep patterns are common, further reducing overall well-being. Beyond the body, cocaine use can profoundly affect relationships and daily life. Because it alters motivation and judgment, individuals may begin neglecting work, school, or family responsibilities. The drive to repeat the experience of stimulation can replace ordinary priorities, creating social isolation and tension. Financial and legal problems can follow as daily functioning becomes increasingly compromised. These combined effects illustrate how cocaine disrupts not only physical health, but also the psychological and social foundations of stability. Recovery from its impact often requires professional medical support and extended time for the brain and body to heal. From a scientific and medical perspective, the reasons to avoid cocaine are clear and well documented. Its effects on the brain and body are not only intense but also enduring, with changes that can persist long after use has stopped. Cocaine's influence on the brain's dopamine system, the network responsible for pleasure, motivation, and learning, can result in lasting chemical imbalances. These changes may cause long-term difficulties with mood regulation, focus, and motivation, even after the substance is no longer present in the body. The cardiovascular effects are among the most dangerous. Cocaine constricts blood vessels, elevates blood pressure, and places extreme stress on the heart. Medical evidence shows that these changes can lead to serious cardiac complications at any age, including among people with no prior health issues. Unlike some substances that build up harm slowly, cocaine can trigger an emergency even with limited exposure. Cocaine's overall impact on health includes weakened immunity, reduced ability to manage stress, and an increased likelihood of anxiety or depression. These physiological and psychological effects create a cycle that can make recovery more challenging. However, the good news is that the brain and body have remarkable capacity to heal once use stops, especially with professional medical care, therapy, and support networks. The safest and most effective decision is to avoid cocaine altogether. The short-term sense of energy or confidence it provides is overshadowed by its long-term risks to health, stability, and well-being. Science consistently shows that prevention and education are the strongest tools for protecting individuals and communities from harm. Understanding how cocaine works and the consequences it brings is the first step toward making informed, healthy choices. Cocaine is often seen as a symbol of power, energy, or success. But the science tells a different story. It's a substance that disrupts the very systems that make us feel alive. Our ability to think clearly, to stay healthy, and to find joy in everyday life. The truth is simple. Every time cocaine is used, it forces the brain and body into an unnatural state. Over time, that strain leaves lasting marks on health, relationships, and future potential. No short-lived sense of confidence is worth what it takes away. But knowledge is power. Understanding how cocaine works means understanding how to protect yourself and others from its effects. If you or someone you know is struggling, help and recovery are always possible. Support from professionals, family, and community can rebuild what this substance tries to break down.